Welcome. What you are about to watch is not science fiction, and it is not folklore. It is a serious investigation into one of history's most compelling unresolved questions: the mystery of Enceladus, Saturn's moon with an ocean, hydrothermal vents, and possible life. Across the world, in universities, research institutes, and field excavations, serious scholars are wrestling with evidence that does not fit the accepted story. Evidence that has been documented, measured, and peer-reviewed, and that still has no satisfying conventional explanation. We are going to look at that evidence carefully, without prejudice in either direction, not dismissing what is extraordinary, but not accepting it without scrutiny either. The truth, as always, is in the details. In 2005, the Cassini spacecraft flew through a plume of water vapor erupting from the south pole of Enceladus, one of Saturn's smallest moons. The water contained organic molecules, silica nanoparticles, and molecular hydrogen, the signature of hydrothermal vents on the ocean floor. Enceladus, a moon the size of England, has a liquid ocean beneath its ice, active geology, and the chemical ingredients for life as we know it. On Earth, hydrothermal vents at the bottom of the ocean support entire ecosystems of life that require no sunlight whatsoever: bacteria, tube worms, shrimp, crabs, all living off the chemical energy of water reacting with hot rock. When Cassini detected molecular hydrogen in the Enceladus plume in 2017, it confirmed that exactly this reaction, hot water meeting rock, was happening on the ocean floor of a moon 4 billion kilometers from Earth. The question is no longer whether Enceladus has the conditions for life. The question is whether it has had those conditions long enough, and whether something has taken advantage of them. The numbers are stark. Saturn is 4 billion kilometers away, and yet Cassini found an alien ocean venting chemistry that on Earth reliably sustains life. In 2023, the James Webb Space Telescope detected Enceladus's plume from 100 million kilometers away and found it stretching 10,000 kilometers into space. The moon is leaking its ocean into the void. We could, in principle, fly through that plume and sample it directly. We have not yet sent a mission to do so. This is where our investigation begins. Stay with us, because the further we go into the evidence, the more extraordinary it becomes. The story you think you know is only the surface. Beneath it lies something far more remarkable. Let us begin. Before we examine the specific evidence, we need to step back and understand the context. This case does not exist in isolation. It sits within the expanding frontier of unexplained cosmic phenomena, and to properly evaluate what we are looking at, we need to understand the broader picture that surrounds it. Space exploration has produced many surprises, but perhaps none as persistent as the anomalies that professional scientists describe and then struggle to explain. These are not the claims of amateur enthusiasts or fringe theorists. They are the published findings of researchers at NASA, the European Space Agency, and major research universities, documented in peer-reviewed journals and presented at professional conferences, then quietly filed under requires further investigation while the scientific mainstream moves on to the next mission. The anomalies take different forms: unexpected geological features on planetary surfaces that do not match known formation processes, electromagnetic signals that arrive from directions where no known source exists, orbital mechanics of small bodies that deviate from predictions of established gravitational models in ways that suggest an additional, undetected force. Each individual anomaly might be dismissed as an instrument artifact or a modeling error. But when anomalies accumulate across multiple missions, multiple instruments, and multiple research teams, the collective weight becomes harder to discount. Science advances precisely by taking anomalies seriously, by treating the things that do not fit the model as invitations to improve the model rather than as embarrassments to be minimized. The history of physics is largely a history of anomalies: the precession of Mercury that Newtonian gravity could not explain, the cosmic expansion that Einstein refused to accept, the dark matter that bends light with no visible source. Each one, properly investigated, expanded the boundaries of what we understand. This context matters because it tells us something important. What we are about to investigate is not an isolated curiosity. It is part of a pattern that researchers in multiple fields have been independently documenting for decades. And patterns in science demand explanation. With that foundation in place, let us now turn to the specific case at hand. Now we reach the heart of the matter, the core evidence surrounding Enceladus, Saturn's moon with an ocean, hydrothermal vents, and possible life, is more extensive, more verified, and more troubling for conventional explanations than most people realize. Let us walk through it systematically, fact by fact, and allow the evidence to speak for itself. We are not going to speculate here. Every point that follows is documented in peer-reviewed publications, official archaeological records, or government archives that are publicly accessible. The question is not whether these facts are real. The question is what they mean. Consider this first extraordinary detail. Enceladus has a diameter of 504 kilometers, making it one of Saturn's smaller moons. It was discovered by William Herschel in 1789, but was considered geologically inactive until the Cassini spacecraft detected water vapor jets at its south pole in 2005. The discovery was unexpected and transformed Enceladus from an obscure icy moon into one of the highest priority targets in astrobiology. This single data point, if taken in isolation, might be set aside. Anomalies happen, instruments malfunction, researchers make mistakes. But as we continue, you will see that this is not an isolated anomaly. It is part of a consistent and documented pattern. But that is only the beginning. Researchers also discovered Cassini's gravity science experiment confirmed in 2015 that the ice geysers at Enceladus's south pole are connected to a global subsurface liquid ocean. The ocean is estimated to be approximately 10 kilometers deep, sitting beneath an ice shell 30 to 40 kilometers thick. Tidal forces from Saturn's gravity flex the moon's interior, generating heat that keeps the ocean liquid, an ongoing energy source that does not depend on proximity to the sun. Now, a skeptic might propose an alternative explanation for this, and that is entirely reasonable. We should always test alternative explanations before accepting extraordinary ones. The problem is that the alternative explanations, when examined carefully, create more problems than they solve. The mystery deepens when we examine. Cassini flew through the Enceladus plume 22 times, sampling its contents with onboard mass spectrometers. The confirmed plume contents include water, sodium chloride, silica nanoparticles, carbon dioxide, methane, molecular hydrogen, and complex organic molecules with masses exceeding 200 atomic units, the kind of large organic compounds associated with biological or pre-biological chemistry, published in Nature in 2018. This is where the conventional account begins to strain. Each individual fact might be dismissed or minimized in isolation, but the cumulative weight of the evidence is another matter entirely. Perhaps most remarkable of all, silica nanoparticles in the plume are particularly significant. Silica nanoparticles of the size detected by Cassini form only when water reacts with rock at temperatures above approximately 90 degrees Celsius, the minimum temperature of active hydrothermal vents. Their presence in the plume is direct physical evidence that hydrothermal activity is occurring at the ocean floor of Enceladus, published in Nature in 2015. Researchers who have examined this evidence have described it as genuinely difficult to explain within the accepted framework. These are not fringe commentators. They are credentialed academics publishing in mainstream journals, raising questions that the field has not yet satisfactorily answered. Then there is the matter of molecular hydrogen, H2, detected in the plume in 2017, published in Science, is the specific chemical signature of serpentinization, a reaction between hot water and iron-magnesium silicate rocks that produces hydrogen. On Earth, serpentinization at hydrothermal vents is a primary energy source for chemolithotrophic microorganisms bacteria that eat rock chemistry rather than sunlight. This makes Enceladus's ocean floor a potential habitat for this category of life. What makes this particularly significant is its independence from the previous points. This is not a case of one theory requiring another. These are separate lines of evidence converging on the same uncomfortable conclusion. Adding to the enigma is this finding. In 2023, the James Webb Space Telescope detected Enceladus's water plume from approximately 100 million kilometers away. Webb's observation revealed that the plume extends more than 10,000 kilometers into space, far larger than previously measured by Cassini at close range. The plume is feeding Saturn's E-ring with water. Webb also detected carbon dioxide and confirmed organic molecule signatures consistent with Cassini's findings, providing independent verification from a different instrument. Taken together, these facts form a pattern that cannot be explained by coincidence, misidentification, or methodological error. Each piece of evidence has been examined by skeptics. Each has been subjected to alternative explanations. And in each case, the alternative explanation falls short of accounting for everything that has been documented. We are left with a body of evidence that demands explanation and an accepted narrative that does not provide one. This is where serious inquiry begins. Now that we have established the evidence, we need to examine the theories that researchers have proposed to explain Enceladus, Saturn's moon with an ocean, hydrothermal vents, and possible life. This is where the debate becomes most intense, because the theories reflect not just different interpretations of the same evidence, but fundamentally different assumptions about what is possible and what the past looked like. Understanding these theories is not just an academic exercise. Each one has been championed by serious researchers with genuine credentials, and each one captures something that the others miss. The truth, if it is ever established, will likely draw on elements of several. The first major explanation proposed by researchers holds that the leading astrobiological hypothesis holds that Enceladus's hydrothermal vent system could support chemolithotrophic life analogous to deep-sea vent ecosystems on Earth. Methanogens, microorganisms that produce methane by combining H2 and CO2, are a specific candidate. Both H2 and CO2 are confirmed in the plume. The main objection is that we do not know how long Enceladus's ocean has been in its current state, and life requires time to originate. This interpretation has significant academic support and is backed by substantial evidence, but it is not without problems. Critics point out that it requires assumptions that go beyond what the evidence strictly supports, and that key predictions of this theory have not been confirmed by subsequent research. It remains contested, and the contest is productive. A rival school of thought argues that the counterargument holds that Enceladus's ocean may be too young or too chemically limited to have generated life. Some models suggest the ocean became liquid only within the past billion years, a short window by Earth standards. Additionally, the ocean's alkaline pH and high salt content, while not prohibitive, narrow the range of viable biological chemistries. Life on Earth took hundreds of millions of years to originate even in favorable conditions. This theory is controversial, and deliberately so. Its proponents argue that the evidence demands an explanation outside the conventional framework. Critics counter that extraordinary claims require extraordinary evidence, and that the evidence presented, while suggestive, does not yet meet that standard. The debate continues in peer-reviewed literature. Perhaps the most unconventional theory suggests that an alternative model suggests that Enceladus's tidal heating is episodic, cycling between warmer and colder periods as Saturn's orbital configuration changes. If the ocean has been intermittently frozen, biological continuity would be interrupted. This view treats Enceladus as a promising but inconsistent habitat rather than a sustained biosphere. The main objection is that current tidal heating appears robust and ongoing, not episodic. What is striking about this debate is not merely that experts disagree, that is normal and healthy in science. What is striking is the quality of the disagreement. Serious researchers, working from the same body of evidence, reaching genuinely different conclusions. That level of fundamental disagreement, when it persists over decades, is a signal that something important has not yet been understood. The question is not which of these theories is right. The question is whether any of them is right, or whether the truth is something that none of the current frameworks has yet been able to capture. The case surrounding Enceladus, Saturn's moon with an ocean, hydrothermal vents, and possible life, does not rest on speculation alone. What distinguishes this investigation from pure mythology is the existence of documented, physical, verifiable evidence, material that has been examined by credentialed researchers and whose authenticity is not seriously disputed. What is disputed is its interpretation. Let us review the most significant documented evidence as objectively as possible. We are not going to cherry-pick the data that supports a preferred conclusion. We are going to lay out what exists and let you draw your own assessment. Physical evidence supporting this account includes Cassini's detection of molecular hydrogen in 2017, published in Science by Hunter, Waite, and colleagues, is the most direct evidence for hydrothermal activity. Paper modeled the H2 concentration and concluded it was consistent with ongoing water rock reactions at temperatures exceeding 90 degrees Celsius. Independent modeling by other teams confirmed the hydrothermal interpretation was the most parsimonious explanation for the observed H2 abundance. This evidence has been subjected to independent verification. Skeptics have examined it. Alternative explanations have been proposed and tested. The data remains. The question of what it means remains open. Investigators have documented the alkaline pH of Enceladus's ocean, estimated at pH 9 to 11 based on sodium carbonate and bicarbonate detected in the plume, matches the pH of Earth's Lost City hydrothermal field, a known vent system that supports abundant microbial life through serpentinization. The chemical parallel is direct and has been noted by multiple astrobiology teams as strengthening the habitability case. This evidence has been subjected to independent verification. Skeptics have examined it. Alternative explanations have been proposed and tested. The data remains. The question of what it means remains open. On-site analysis revealed the 2023 Webb Space Telescope observation independently confirmed Enceladus's plume and its organic molecule content using infrared spectroscopy, a completely different detection method from Cassini's mass spectrometry. The agreement between the two independent instruments and methodologies eliminates instrument artifact as an explanation and confirms the plume chemistry is real and ongoing, not a historical residue. This evidence has been subjected to independent verification. Skeptics have examined it. Alternative explanations have been proposed and tested. The data remains. The question of what it means remains open. Each individual piece of evidence might, in principle, be explained away. A single anomalous artifact might be misidentified. A single anomalous date might reflect contamination. A single anomalous eyewitness account might reflect misperception. The question is whether all of the evidence can be explained away, and whether the explanations required are more or less plausible than the evidence itself. When multiple independent lines of inquiry converge on the same conclusion, that convergence is the most powerful signal in empirical science. And that is exactly what we are seeing here. We have examined the history, the evidence, and the theories surrounding Enceladus, Saturn's moon with an ocean, hydrothermal vents, and possible life. Now we need to ask the question that is sometimes overlooked in discussions of ancient mysteries. Why does this matter? What does it mean for us today? It would be easy to file this away as an interesting historical curiosity, a puzzle from a distant past with no bearing on our present lives. That would be a fundamental mistake. The questions raised by this case touch on issues that are directly relevant to who we are, where we came from, and what the human story actually looks like before the period covered by conventional history. The Cassini mission ended in September 2017, when the spacecraft was deliberately crashed into Saturn to prevent biological contamination of its moons. No follow-up Enceladus mission is currently funded, though the Enceladus Life Finder concept has been proposed multiple times to NASA. Europa Clipper, launched in October 2024, will study Jupiter's moon Europa and provide comparative data on ice-covered ocean worlds. Enceladus is now ranked by most astrobiologists as one of the 2 or 3 best candidates for extraterrestrial life in the solar system, alongside Europa and Mars. A plume sample return mission is technically feasible and would provide definitive evidence. The plume material is already in space, requiring no landing. Furthermore, the tools available to investigate these questions are advancing rapidly. Satellite imaging, ground-penetrating radar, ancient DNA analysis, isotopic tracing, and deep-sea sonar are all providing capabilities that previous generations of researchers could only dream of. Cases that were genuinely unresolvable 10 years ago are now open to new analysis, and the findings, consistently, are expanding rather than contracting the mystery. The investigation continues. New discoveries are being made. New analyses are being published. New voices are entering the conversation from disciplines that were not previously part of the discussion. The answers, when they come, and they will come, will not merely solve a historical puzzle. They will force a fundamental revision of assumptions that underpin our entire understanding of human history and human potential. We have now walked through the complete case of Enceladus, Saturn's moon with an ocean, hydrothermal vents, and possible life, from the historical record, through the physical evidence, across the competing theories, and into the modern significance of what remains unresolved. What the story of Enceladus ultimately reveals is not just a historical puzzle. It is a mirror. It reflects our assumptions back at us, our assumptions about what ancient people were capable of, about how knowledge is gained and lost across the centuries, and about the relationship between what we know and what we merely think we know. The evidence presented in this documentary is real. The questions it raises are genuine. The debate among researchers is ongoing, and that is healthy. Science is not a set of conclusions. It is a process. And the process requires that we remain open to evidence that challenges what we thought we knew, however uncomfortable that challenge might be. If you came to this documentary as a skeptic, we hope the evidence gave you something to think about. If you came as a true believer, we hope the critical examination gave you a more nuanced picture. The truth, as always, lies in the evidence, not in what we want to be true. Thank you for watching. If this investigation sparked your curiosity, please subscribe to the channel. We publish new documentaries every week, covering the full range of historical mysteries that the mainstream has not yet adequately explained. Leave a comment below telling us which case you want us to investigate next. The conversation continues. The investigation never ends.